Alright, cancellation law of addition. This one is a little bit tricky. You have to remember that sometimes the English word for something doesn't always match what it does in mathematics. This would be a good example of that. So there may not be anything being cancelled. It's called the cancellation law. Let me repeat that. Just because it's called cancellation law doesn't mean that you're canceling anything. You really should. It's kind of a bad name. They should have named it something else. But I wasn't there at the memo. I didn't get the memo, or I didn't get invited to that meeting. Here it says that if x equals y, if you have an equation, then x equals y. But here's the trick. It says that you can add stuff to both sides. I can add any number I want to both sides. That's what the cancellation law says. It says you can add stuff to both sides of the equation and it will still be true. Now you may have heard before that whatever you do to one side of the equation you should do to the other and you'll be fine. That's actually not true. It's sort of deceiving. You should be much more careful than that. However, this one says that this is okay to do to both sides. You can add a number to both sides and you'll be safe. Just as a little example of why that might be dangerous to think that whatever you can do on one side you can do to the other. Consider this -1 squared is equal to 1 square, and well, that's because, well, you don't know that yet, but suppose you did. -1 times -1 is +1, and +1 times +1 is 1. So clearly both squares are equal. The square of this is equal to the square of that because they both equal to 1. However, suppose you go on this naive idea that whatever you do to one side I can do to the other side, then you'd run into trouble because you say, alright, I'm going to take the powers off of both sides because whatever I do to one side is I do to the other. And now you've got something absurd. -1 is equal to +1? Not always, not really. Unless you're Chuck Norris. This is not true. So, be cautious. Be passionate about knowing every single step with certainty. And don't be doing stuff like this. Here's what's safe to do. This one says it's safe to add a number to both sides. That's it. We can add stuff to both sides. That's okay. Nobody said anything about whatever you do to one side you do. No. Especially taking powers away. Very dangerous. Alright, so that's what it says. You can add stuff to both sides. It applies to all the numbers in our class. Practice it. Here's why sometimes people call it cancellation. I'll have you practice it. Suppose I have x plus 3 is equal to 7. What people have done in the past is they've used this to say, you know what, I want to cancel that 3. The perfect way to cancel that 3 is to add a killer. I'll add a killer to both sides and then I'll cancel it. That's where it gets its name from. But maybe sometimes nothing gets cancelled. It's still safe to add stuff to both sides. This is called cancellation law of addition. I add stuff to both sides. I use the icon here. You're adding stuff on both sides of the equation. On that side of the equation and on that side of the equation you're adding the same number. That's why the icon is what it is. And this is one of the ones that comes in pairs. So there's another one just like it for multiplication. Let's have a look at that one. The one for multiplication would say that you can multiply on both sides, obviously. So it would look like this. This one has an if and then format. If x is equal to y, then wait, let's go with the other so we're consistent like we did on the other one. So we're gonna go with if x equals y, then x equals y, except that now we slap a number on both sides. I say, hey, I can multiply both sides by any number I want, a. Here it's important to add the parentheses, I think, because sometimes if this is more than one term, you're going to get in trouble if you don't multiply the entire side by a. This says you can multiply the entire side of a, and the entire side of, the entire left side by the number, and the entire right side by the same number. But it's very important that you do the entire side. Alright, so for example, suppose I have, let's switch back to yellow. So suppose, as an example, I have 3x plus 1 is equal to 12. Okay? Suppose this is given. If I wanted to, I could write 3x plus 1 is equal to 12. I could slap a 1/3 on this side, so long as I slap a 1/3 on this side. But if I do this exactly as it is, I would get the wrong answer, because the 1/3 has to be multiplied times the entire side. As it is here, this is being glued together to the 3x, making one term here. So that the 1/3 never gets multiplied. The 1 never gets multiplied by the 1/3. So as it is, it would be incorrect. That's why you got to add the parentheses here, and then you'll be safe. Okay, that's called cancellation law of multiplication. I multiply both sides by something. Perfectly legal to do that. Okay, that's what it says. Applies to everything in our class. That's how you practice it. Slap something on both sides. You multiply both sides by whatever you want. Here, I'll give you one more example. Tell you when it's useful. Suppose I have 5x is equal to 20, right? That was given. Suppose that was given. I could say 5x is equal to 20, and then I could slap a 5 killer on both sides. Multiplicative killer, because these being multiplied times the x. Multiplicative killer on both sides. And the reason I can do that is by cancellation law of multiplication. Then I can rearrange this, so I make 1/5 times 5 times x is equal to 1/5 times 5 times 4. So what did I do here is associative law of multiplication. I slide the parentheses over. Here I broke up the 20 into 5 and 4. Why? Because I needed a 5 killer. I have a 5 killer out here. If I have a 5, they'll kill each other, and that'll just leave me with the answer. So I did times table on the right hand side. Now I do 1 times x, because those are multiplicative inverses. They're killers of each other, they give you 1. And I do 1/5 times 5. This is associative law of multiplication on the right hand side. That gives me 1 times 4, multiplicative inverses. The 5 killer and the 5 kill each other, they give you 1. And then the 1 times anything is just the same thing. That's multiplicative identity. 1 is like water. It does nothing. So, yippee-ki-yay, I've got the answer, x equals 4. Not only do I have the answer, class will never be about the answer. If I really just wanted the answer, I'd ask Siri. I bet you Siri knows how to figure this out. I'd say, Siri, what is solve 5 times x equals 20? And I bet you Siri would solve it for me. 5x equals 20. Solve.
Let me think. Okay, check it out.
I told you. See? If this was just about... If this was just about getting the answer, we could quickly be done that way, but the time is gone when answers were of any use at all. Anybody can... They're so cheap now, everybody can get the answer. It's about thinking, and this is the most logical and perfect way of thinking about something that there is in mathematics. Stuff like this, it's near perfection. Every single step as explained as we could possibly do it at this level. Alright, that's the cancellation laws. Maybe we should wrap it up. Let's do a little summarizing. Yeah, reflexive property. A rose is a rose is a rose. Works for any of the numbers in our class, not for future classes. Symmetric property, you can switch the equality. Transitivity property, if A equals B and B equals C, then the first one equals the last one. You glue these together. Okay? Cancellation laws, you can add stuff to both sides. Really, they should be called the add stuff to both sides laws. Cancellation law of multiplication, you can multiply both sides by something. You see the parentheses here, it's kind of important, especially if you have more than one term. That's it. That's our last dose for the initial axioms. These are called ring axioms, if you want to be fancy about it. There's not that many more. The rest of the course will still have some axioms and definitions, but they won't be as dense. We've done most of them already. So learn these well. I'm going to have a lot of flashcards to do. It's incredibly important that we learn the rules. Otherwise, it's silly to play the game. And we're going to get started next week on proving everything and understanding everything as deeply as we can. All right, we'll see you guys here next time. Peace. Come on now. What?